Hello, 108 class. Mr. McHugh here on section 8.3 bonus page number 4. I'd like to show you how to do the distance formula and correlate it with the Pythagorean theorem and how you could use the visual approach to solving this problem. In case for students who are visual, I do this on the board, and many students grasp what the formula says here, and what's really going on is basically the Pythagorean theorem. Okay, so here's the story. We're on given 2 points. We're doing example 9 on page 450 out of the book, and they ask you to find the distance between two given points. They give you 6, 4 and -3, 5. Now, first tip, write these ordered pairs in vertical format. Do not write them horizontal. It's much more easier because you're finding you're going to take the distance, the horizontal distance, and you're going to figure out the vertical distance. Okay, so write them vertically. Label the top one x2, y sub 2. Label the bottom one x1, y sub 1 for the ease of convenience of when you're going to subtract. You're going to subtract going top to bottom. Okay, now here's the deal. Nothing wrong with the distance formula. They give it to you in the book with the big square root. I strongly encourage you to use my way here of saying d squared, which is the distance, the red line, the distance between the 2 points, the distance squared, equals the horizontal distance. X is horizontal. That horizontal distance squared plus the vertical distance squared. Okay, now let's go back to the Pythagorean theorem. I try to set up a graph here. If you graph these 2 points, -3, 5, 6, 4, you're about right here. And I have a quick question. How many points are you going? How many units are you from horizontally on the green from -3 up to 6? Okay, now you could see -3. 1, 2, 3. Add 6 more. So you're going 3 plus 6, and you've gone a whole total of 9. Okay, so when I'm going to I need to squeeze this out here, so hold on here. So this is the hypotenuse squared equals the horizontal squared plus the vertical squared, aka c squared equals a squared plus b squared. Okay, Pythagorean theorem. Okay, now so here we go. We are going to find the hypotenuse. Oh, by the way, here's the right triangle that I've formed between the 2 points. Here's the horizontal distance. Here's the vertical. I call that the turning point right there. That's how you form the right triangle. We need to find that hypotenuse. So we're going to call it. I'm going to use D just because that's what we use in the distance formula. You could use C. It doesn't really matter. Okay. Now, what's the horizontal distance? How many units? From -3 to 6, 4. We did this already. 3 plus 6, you get 9. You're going to square it. Okay, now what is the vertical distance? From 4 to 5 on the y-axis, y-coordinates, you're only going the distance of 1. This is distance of 1 between 4 and 5, and you're going to square it. Okay, that's all you're doing. So I love teaching this in class. You get 81 plus 1. D squared equals 82. How do you figure out the distance? Take the square root on both sides, and D will equal the square root of 81. Oops. Okay, now that's going to be your answer. Oop, square root of 82. What did I say? 81. Square root of 82. Okay, now there you go. You could be done if you take a little bit of time graphing, get a visual going. Can we come down here? You're allowed to write this on your formula sheets for tests and for the final. And it's telling you to figure out the horizontal distance and square it using the coordinates, the coordinate pairs, x sub 1, x sub 2, y sub 2, x sub 1, y sub 1. So I love the vertical stacking. Okay, so here we go. The distance squared. Again, the red line represents the hypotenuse of the right triangle. It's going to equal, let me go to green mode here, x2, which is what? 6 minus a -3, quantity squared. Okay, bear with me as I'm using different colors here to help us see this. Vertical distance, 4 minus 5. Quantity squared. Sorry about my right. Okay, 4 minus 5. Is everybody comfortable with that? If you like mechanical label your ordered pairs and substitute in. You don't want to do any graphing, that's fine. You're going to get the same answer. So let's just keep it going here. Here's d squared. Now we're going to get 6 minus a minus 3 class is what? That's right, 9. 9 squared, 81. Okay. What's 4 minus 5? Negative 1. Negative 1 squared is 1. Oh boy, looking pretty familiar, isn't it? So d squared equals 80. Oops, I keep putting 82. Take the square root on both sides, and the square root of 82 is your answer. And voila, we've done it. Proven it both ways. Exact same answer in the book, by the way. Now your calculator, if you punch in the square root of 82, it'll give you the decimal equivalent to it, but the book wants you to put these in with radicals in there. Okay, I'm hoping you like that. A chance for me to explain that distance formula with visual method and how to stack and do that subtraction. Another little technique here when you're subtracting, I like to show a little subtraction sign. So you say 6 minus a minus 3. There's where you got your 9 over here and over here too. 4 minus 5 is negative 1, and negative 1 squared is 1. So I like those visuals, make life easy for you. Okay, Mr. McHugh, we are finally going to wrap up 8.3, and I see you in the next video we'll start 8.4. Okay, take care. Bye.